All right, our last objective for Power Focus Area 9, all about electromagnetic waves. So now we'll talk about more than just light as an electromagnetic wave. Here are the 7 different types. We've already talked about visible light, but we also have gamma rays, infrared, radio waves, microwaves, UV light, visible light, and we'll kind of explore the difference between each of those in terms of frequency and wavelength after you add them to your note guide. So go ahead and press pause, type those in, and then we'll go on. All right, so this is a picture of the electromagnetic spectrum. All it does is list all seven of those waves in order from biggest wavelength, like we see down here at the radio wave, to the smallest wavelength, like the gamma, or we can look at the highest frequency. The waves are crammed together on the gamma ray side to the biggest frequency or longest frequency on the radio side. And this shows you the same thing, except we add one important piece here. If you have high frequency, you also have high energy. So gamma rays are super energetic, actually dangerous. X-rays can be harmful. We know UV light is harmful from the sun. That's why you wear sunscreen. And then stuff like radios and microwaves, they're not very much energy at all. And that's why we use things like Wi-Fi and cell phones are transmitted through radio or microwaves. So a bunch here. You'll definitely need to pause as you put this in your note guide. So what is true? This has not been in the notes yet, so see if you remember. I didn't say it anyway. You could have read it. What is true about all EM waves? What's the same for them? So press pause while you answer. Be careful. It's no longer energy. Energy was just our wave answer. That's what moves through waves for EM waves is they all travel the same speed. They all go ridiculously fast through outer space, and they go the exact same speed. Oops. Waves that have higher frequency also have higher what? So look over here. Gamma rays, X rays are the high frequency waves. Press pause while you answer on your Pear Deck. And the answer is energy. More frequency is more energy. All right, our favorite word here, electromagnetic waves. Hold on, why is my pen not working? I'll use a laser. So our word electromagnetic waves has 2 words built in, electro meaning electric and magnetic meaning magnetic. And how are they made? Well, they're made by vibrating electroelectric, and magnetic fields. Go ahead and make sure you put this into your note guide. Here's the answer to that one practice question. We'll put it in our notes soon, but I wanted to see what you remembered from way back when. All EM waves do have the same speed. And I said it was ridiculously fast. Well, there's the number. 300 million meters per second. So that's 30 million football fields every single second. That's ridiculous. And that's not just light waves, it's radio waves, gamma rays, all of those. But we've already seen through the electromagnetic spectrum that even though they go the same speed, they have different wavelengths, different frequencies, and different amounts of energy. So go ahead and add this to your note guide. Press pause before I move ahead. When we're talking about just visible lights, just this middle part of the spectrum, look how red is more towards the radio wave side. So red has the longest wavelength of visible light, and therefore the lowest frequency and the least amount of energy. Blue and purple are more toward the gamma ray side, so they have higher frequency and slightly more energy. So go ahead and add this to your note guide. What color of light has the shortest wavelength? Just use this picture, press pause. Short wavelengths are down here, so purple would be the shortest, then blue, then green, and so forth. On this one, you're going to draw on your Pear Deck slide and circle the name of the EM wave that has the shortest wavelength. Not the color, but the EM wave, so from these names. If we look, these wavelengths down here are short, it's gamma rays. What EM wave has the most energy? Press pause while you answer. Remember, high frequency stuff down here means high energy. So gamma rays have the most, then X-rays, then UV. Which EM wave moves the fastest? Press pause while you answer. Hope you weren't tricked. This is the thing we said is the same, so all EM waves have the same speed. So if you remember, this is one of the harder things we learned when we were talking about EM waves, is that EM waves have something we call wave-particle duality. Remember, we said dual means two, and then we just look at the two words before it, wave and particle. So all light and EM waves act both like a wave, there's the word, and a particle. So wave-particle duality means we act like a wave and a particle, both of those words. Go ahead, add this to your note guide. Press pause before I switch it up. Go ahead and add this. There may be one question on one of these. We're not going to go in great depth, but if you remember, diffraction is when light or any wave spreads out after it goes through a little opening. Refraction is when light bends. Interference is that black and white pattern when waves combined. Reflection is bouncing. And Doppler effect, don't worry, it's definitely not on the test. A little bit more of our notes. Press pause if need be. And that's it, a short little objective to end it.